Hi, and welcome to another TOEFL prep lesson. Today we're going to be doing the listening section again. We're going to continue a little bit with some more exercises. Last time we did a lecture and we did at least a conversation with a professor and a student. And so today we're going to do at least 3 more examples. So one of them is going to be a lecture with students participating, and we're going to do a conversation that's not necessarily with a professor, but it would be a student in a campus situation. So for example, in a library. And we're also going to do another lecture so you can get another experience with that one. So I'm going to start sharing my screen here, and then we will go into the audio files and I'll play those, and then we'll go through the questions. So thank you everybody for watching this, and let me get sharing the screen now. Okay, so just checking to make sure that you can see my screen. So this says TOEFL lesson number 15, and we're continuing on from lesson 14, which was a couple more listening exercises. So once again, in the listening section, you have a combination of conversations between students, professors, and also other university faculty or university employees and students. You have lectures with students who participate by asking questions. And you also have lectures where the professors just speak by themselves without any interruptions or questions. And if you are taking the normal version of the test with no experimental material, you will have 60 minutes to listen to 6 audio files. So that will be 2 lectures with the professor by himself or herself, and 2 lectures where students participate, and 2 conversations. If you have an experimental version of the TOEFL in which they are adding material to just test it out to see if it works, you will have an extra 1 of each type. So an extra conversation, an extra lecture with student participation, and an extra lecture without student participation. And as I said before, I would recommend on a piece of paper with your notes, kind of keep track of where you are in the listening section, so you know kind of how many you've done and how many more to kind of anticipate. So for the conversations, you'll have 5 questions, and typically at least one of the questions with conversation, you will listen to a brief extract of the audio, and there might be a question about like, well, what does the teacher imply, or what is the intention? And that would be probably related to their intonation about what is that they're trying to express with their voice. And you'll have 6 questions for the lecture. So you can only listen to this 1 time. So it's really important that you take good notes. And again, the types of questions that you might have here is just basic comprehension. So this could be the main idea or purpose or the details that are being discussed. Some of the questions might be, what are 2 types mentioned, or 2 ways to distinguish or characterize. So in those cases, that kind of question, you might have 2 answers that you have to provide for that. You might also have to kind of infer and kind of connect the dots with the information that you receive. And also with the pragmatic one is kind of listening to the quality of their voice in terms of like their intonation, or how they're expressing certainty or doubt or clarification. So you might have to listen to that in their voice. Okay, so let's get into an example here. So we're going to listen to part of a lecture in an environmental science class. So I would recommend that if you have a piece of paper and a pen or pencil, to take some notes. And then after we finish this listening, I will show you some of my notes that I took during this listening. So this is about close to 5 minutes, but I'm going to get started here.
Listen to part of a lecture in an environmental science class.
So since we're on the topic of global climate change and its effects, in Alaska, in the northern Arctic part of Alaska, over the last 30 years or so, temperatures have increased about 0.5 degrees Celsius per decade. And scientists have noticed that there's been a change in surface vegetation during this time. Shrubs are increasing in the tundra. Tundra is flat land with very little vegetation. Just a few species of plants grow there because the temperature is very cold and there's not much precipitation. And because of the cold temperatures, the tundra has 2 layers. Top layer, which is called the active layer, is frozen in the winter and spring, but thaws in the summer. Beneath this active layer is a second layer called permafrost, which is frozen all year round and is impermeable to water.
So, because of the permafrost, none of the plants that grow there can have deep roots, can they?
No, and that's one of the reasons that shrubs survive in the Arctic. Shrubs are little bushes. They're not tall, and being low to the ground protects them from the cold and wind. And their roots don't grow very deep, so the permafrost doesn't interfere with their growth, okay? Now, since the temperatures have been increasing in Arctic Alaska, the growth of shrubs has increased. And this has presented climate scientists with a puzzle.
I'm sorry, when you say the growth of shrubs has increased, do you mean that the shrubs are bigger or that there are more shrubs?
Good question, and the answer is both. The size of the shrubs has increased, and shrub cover has spread to what was previously shrub-free tundra. Okay, so what's the puzzle? Warmer temperatures should lead to increased vegetation growth, right? Well, the connection's not so simple. The temperature increase has occurred during the winter and spring, not during the summer. But the increase in shrubs has occurred in the summer. So how can increased temperatures in the winter and spring result in increased shrub growth in the summer? Well, it may be biological processes that occur in the soil in the winter that cause increased shrub growth in the summer. And here's how. There are microbes, microscopic organisms that live in the soil. These microbes enable the soil to have more nitrogen, which plants need to live, and they remain quite active during the winter. There are 2 reasons for this. First, they live in the active layer, which, remember, contains water that doesn't penetrate the permafrost. Second, most of the precipitation in the Arctic is in the form of snow, and the snow, which blankets the ground in the winter, actually has an insulating effect on the soil beneath it, and it allows the temperature of the soil to remain warm enough for microbes to remain active. So there's been increased nutrient production in the winter, and that's what's responsible for the growth of shrubs in the summer and their spread to new areas of the tundra. Areas with more nutrients are the areas with the largest increase in shrubs.
But what about runoff in the spring, when the snow finally melts? Won't the nutrients get washed away? Spring thaw always washes away soil, doesn't it?
Well, much of the soil is usually still frozen during peak runoff, and the nutrients are deep down in the active layer anyway, not high up near the surface, which is the part of the active layer most affected by runoff. But, as I was about to say, there's more to the story. The tundra is windy, and as snow is blown across the tundra, it's caught by shrubs, and deep snowdrifts often form around shrubs. And we've already mentioned the insulating effects of snow. So that extra warmth means even more microbial activity, which means even more food for the shrubs, which means even more shrubs and more snow around them, etc. It's a circle, a loop. And because of this loop, which is promoted by warmer temperatures in the winter and spring, well, it looks like the tundra may be turning into shrubland.
But will it be long-term? I mean, maybe the shrubs will be abundant for a few years and then it'll change back to tundra.
Well, shrub expansion has occurred in other environments, like semi-arid grassland and tall grass prairies. And shrub expansion in these environments does seem to persist, almost to the point of causing a shift. Once it's established, shrubland thrives, particularly in the Arctic, because Arctic shrubs are good at taking advantage of increased nutrients in the soil, better than other Arctic plants.
Okay, so now let's take a look at some of the notes that I have taken for this. Okay, so what the professor is talking about here is that there's been changes due to global climate change and the effects in Alaska over the last 30 years. And there's been an increase of about half a degree of Celsius. And so there's an increase of surface vegetation. So that's the shrubs in the tundra, which is the flat land. It's very cold. There's not much precipitation. Precipitation could be like rain or snow. And she says that there's 2 layers of the soil. There's the top active layer, which is frozen in winter and spring, and then that thaws, meaning it like unfreezes in winter and summer. And then there's a second deeper layer called the permafrost, and that is permanently frozen throughout the year. So plants can't have long roots because they can't penetrate or go through the permafrost. So, the shrubs are not necessarily stopped by the permafrost because they have a very low, shallow roots. They're just these small bushes. So they're not tall like trees that require these really long roots, and they can withstand wind. So the permafrost is not a problem for those plants. So when there's a question about being bigger, is that like are their size is bigger or there's more of them? And the professor says that it's actually both, that there's an increase in their distribution and also that they are getting bigger in size. And there's a puzzle or a question here in terms of, well, if there's an increase in the vegetation and there's an increase in the temperature, but the temperature is only in winter, not during exactly the summer season when these shrubs are increasing. So she's wondering what the connection is, and says that there's actually probably some biological growth going on in the soil, that there's microbes, like little organisms that are producing maybe more nitrogen in the soil. And nitrogen is meaning there's more nutrients, and that the shrubs have basically more food that they can use to grow. So these microbes live in the active layer where there's water and basically the snow. And there's a question from the one of the students about what happens with the kind of runoff about, well, don't these nutrients kind of disappear when the spring water rushes over the active layer? And the professor says that no, that's not actually a problem, because there's more of this nutrients in the deeper part of the active layer, and that the snow in winter has an insulating effect in which the plants and the microbes kind of stay warmer and don't completely freeze or die. So by the time spring and summer happens, those nutrients are still in the soil, and this creates kind of a loop in which the vegetation continues to increase and grow each season or each cycle of that. So, and there's a question about, well, is that going to be a permanent change, or is this going to just happen for a few years? And the professor makes a comparison to semi-arid grassland, in which these other plants, shrubs, have kind of adapted and established themselves. And so the tundra could have a permanent change due to these shrubs that continue to spread. So those are some of the notes that I've taken and my understanding based on this, this listening. So let's get into the questions here. So what is the lecture mainly about? Is it the factors involved in the increased growth of shrubs in Arctic Alaska? I think it's that one, but I'll keep going. How temperature increases might be affecting the permafrost in Arctic Alaska? No, the temperature increase is not affecting the permafrost. The permafrost stays frozen throughout the year, so that's not being the main point here. Why nutrient production and microbes in the soil in Arctic Alaska is declining? Actually, it's the opposite. The professor says it's like increasing. So that would be a kind of, they would have some key words there, but the conclusion is wrong. Reasons that grasslands are turning into tundra in Arctic Alaska, that's just confusing two different points. The grasslands was a comparison, and here we're talking about tundra, where there's like extreme cold and not much can grow there. So I would say the answer here is A. Next, according to the professor, what are two features of shrubs that allow them to grow well in Arctic regions? So choose two answers. They have roots that can penetrate permafrost. No, that's wrong. These are little plants, so they don't have deep roots. Their height allows them to absorb more sunlight. No, that wasn't discussed. They didn't talk about the sunlight there. So basically A and B are wrong. So right now I already know that I would expect that C and D are these two choices, and I'll just look at them briefly. They absorb nutrients from the soil efficiently. Yes, that is true. And they have a shallow root system. So shallow is not deep, and that makes sense because nothing can really penetrate or permeate through the permafrost layer. So I would say C and D here about the nutrients, and that they're shallow, not deep for their roots. Next, number 3, what is one reason for the increase in shrub growth in Arctic Alaska? So decreases in grass and moss growth. They didn't talk about the moss or grass that have altered the balance of nutrients. No, that's wrong. They didn't talk about that. Increases in ground temperature have led to increased microbial activity. I believe that's true. That is what she did talk about. Increases in average winter temperatures have made permafrost permeable to water. No, that's not true. The permafrost still stays frozen, so that's a wrong conclusion here. Next here, increases in snowfall have provided more water for shrubs. No, that wasn't this reason. So I would say here it's B. The ground temperature has meant that the microbes have been able to survive during winter, and then that it becomes food and nutrients for the shrubs. Next, why are nutrients in the soil not carried away by spring runoff? The professor said something that it was in the deeper part. So let me see here. The roots of shrubs prevent nutrient-filled soil from being washed away. No, it wasn't. It's not because of the roots. Most nutrients are not in the area of the soil most affected by runoff. Yeah, that's true. She said it was in the deeper part, and the top part is usually where the runoff carries away these nutrients. So I would already start to say B, but I'll keep reading. Most nutrients remain frozen in the permafrost when spring runoff is at its peak. No, it's not in the permafrost. It's in the active layer. Most nutrients have been absorbed by vegetation before the runoff period. Well, no, because during winter, these plants would not be alive. These shrubs are active in summer. So no, that's just a wrong conclusion there. So I would say it is here B. Most nutrients are not in the area of the soil most affected by runoff. Okay, next. Why does the professor mention shrub expansion into other environments, such as semi-arid grasslands? I think she uses this as a comparison. So to suggest that new shrubland may not convert back to tundra, could be. To explain how shrubland can expand in a warm climate, no. To cite a similarity between the types of shrubs in semi-arid grassland and tundra environments, no, it wasn't exactly the types of shrubs, no. To explain how a biological loop can cause shrub expansion, no, that's kind of a bit of a wrong conclusion here. I would say that the point she's trying to make here is that it's likely that it's not going to be reversible. So yes, I would say A here to suggest that new shrubland may not convert back to tundra. That's why she mentions this point, because the student asked about, is this going to be temporary or permanent? Okay, this last question here, I'm going to play the audio so you can listen to this.
What does the professor imply when she says this?
So what's the puzzle? Warmer temperatures should lead to increased vegetation growth, right?
Okay, so there was a question here about what does she imply there? So the information you gave is important? No. Climate scientists are asking the wrong question? No. The phenomena she's describing is more complex than fears? Yes. I would say this is C. Students should be able to solve the puzzle. No, she doesn't. No. Yeah, I would say this is C, that is more complex than it seems at first. So basically the questions and the answers here are, what is the lecture mainly about? These factors involved in the increased growth of shrubs in Arctic Alaska. 2, according to the professor, what are the 2 features that allow them to grow well? So it is the fact that they absorb nutrients efficiently and that they have a shallow, meaning not deep, root system. Next, this 3, one reason for the increase in shrub growth, it's because of the ground temperature that has allowed these microbes to stay active and warm in winter. Why are nutrients in the soil not carried away? Because they're not in the area of the soil or the part of the soil that's affected by the runoff. They're in a deeper part of the active layer. Why does the professor mention the shrub expansion into other environments? To suggest that this may not convert back to tundra. So it's not reversible. So it's irreversible, this effect. What does the professor imply when she says, so what's the puzzle? Warmer temperatures should lead to increased vegetation growth, right? The phenomenon she's describing is more complex than it appears. So hopefully you got those answers. So this is one section. We're going to move on to the next one, which is a conversation between a student and a library employee. So I'm going to now play this audio file. And again, I'd like you to take notes, and then we'll take a look at the notes and take a look at the questions.
Listen to a conversation between a student and a library employee. Excuse me, can you help me with something?
I'll do my best. What do you need?
Well, I received a letter in my mailbox saying that I'm supposed to return a book that I checked out back in January. It's called Modern Social Problems. But because I'm writing my senior thesis, I'm supposed to be able to keep the book all semester.
So you signed up for extended borrowing privileges?
Yeah.
But we're still asking you to bring the book back?
Uh-huh.
Well, let me take a look and see what the computer says. The title was Modern Social Problems?
Yeah.
Okay. Oh, I see. It's been recalled. You can keep it all semester as long as no one else requests it, but someone else has. It looks like one of the professors in the sociology department has requested it. So you have to bring it back, even though you've got extended borrowing privileges. You can check out the book again when it's returned in a couple of weeks.
But I really need this book right now.
Do you need all of it, or is there a certain section or chapter you're working with?
I guess there's one particular chapter I've been using lately for a section of my thesis. Why?
Well, you can photocopy up to one chapter of the book. Why don't you do that for the chapter you're working on right now? And by the time you need the rest of the book, maybe it'll have been returned. We can even do the photocopying for you because of the circumstances.
Oh, well, that would be great.
I see you've got some books there. Is that the one you were asked to return?
No. I left it in my dorm room. These are books I need to check out today. Is it okay if I bring that one by in a couple of days?
Actually, you need to return it today. That is, if you want to check out those books today. That's our policy.
Oh, I didn't know that.
Yeah, not a lot of people realize that. In fact, every semester we get a few students who've had their borrowing privileges suspended completely because they haven't returned books. They're allowed to use books only in the library. They're not allowed to check anything out because of unreturned books.
That's not good. I guess I should head back down to the dorm right now then.
But before you go, what you should do is fill out a form requesting the book back in 2 weeks. You don't want to waste any time getting it back.
Thanks a lot. Now I don't feel quite so bad about having to return the book.
Okay, great. So let's take a look at some of the notes that I've taken here. So this student received a letter about having to return a book, and the student thought that he could keep this book because he has extended borrowing privileges, meaning that he is allowed to keep this for a long time. But for some reason, the library is asking him to return the book. So they give the title Modern Social Problems. That's not really very important to know, but that is being recalled or requested by a professor. And so despite his privileges, he needs to return this book. So, and then the librarian asks him, well, does he need all of the book? Because he's a bit concerned that he needs this for his thesis paper. So she asked that because he would be allowed to copy or photocopy a chapter from it, that he could kind of keep that photocopy while he's waiting for the book to be used by this professor, and then he could get it back again when the professor returns it. He also has some books that he wants to check out today. However, the librarian says, well, if you don't return this book that's being requested, he won't be allowed to check out any new books, so that they have a policy in place that he has to return this book. And she reminds him that some students might lose their privileges if they don't return books. So that's kind of explaining what would happen if he doesn't go get that book today. And then he says, okay, he's going to go get the book. And she says, you should fill out a form to request the book as soon as possible, so that he won't have any delays with being able to get that book back for his research. So that's a lot of the notes that I've taken here. This is a bit more straightforward. It's not as difficult as some of the lectures, maybe. So this is just kind of this conversation, kind of figuring out what's going on with the policy and with the situation, and then going through with this. So, okay, let's get into the questions here. So what are the speakers mainly discussing? A book that the man is trying to find in the library? No, he has the book. A book that the man already returned to the library? No, he has it, he didn't return it yet. A book that the man is using to write his thesis, the senior thesis? Yes, this would be letter C. A book that the man lent to his sociology professor? That would just be confusing things. So it's letter C, it's choice C. What does the woman offer to do for the man? Let the man know when a book he needs is returned? No, he has to return it. Photocopy a chapter of a book for him? Yes, she does offer to do that while he can't use the book. Ask a professor to return a book the man needs? No, it's the opposite. He has to return it because a professor wants it. Find a copy for him at another library? No, they don't talk about other libraries. So this is B. She offers to photocopy part of the book, a chapter of it, that he can use while the other professor is using the book. So, okay, next on here. What is the man trying to explain when she mentions students have lost their borrowing privileges? Why the man should not photocopy the book? No. The reasons for one of the library's policies. What will happen if the man does not return the book? The reason the man has to fill out a form. Actually, I think there's might be a small typo here. I think it should be, what is the woman trying to explain when she says, yeah, so the woman, the library, sorry about that little confusion there. Okay, so I think this is trying to explain to him what will happen if he doesn't return the book, saying that there's a policy and that he could lose his privileges. So this is the woman, what the woman is trying to explain. Okay. How does the man probably feel at the end of the conversation? Annoyed. He to pay a fine? No, he doesn't have to pay a fine. Upset that he will lose his library privileges? Well, he's not going to lose them provided that he brings this book back. So he's not necessarily upset. No. I'm glad that he can keep the book for 2 more weeks. No, she said he has to return it today, so he can't keep it any longer. Appreciative that the woman is helping him? I believe that's true. Yeah, I think these other 3 choices are wrong. So I would say this is choice D, that he's appreciative, because he does say something like, oh, that's good to know. I'm a little less worried. So the woman does seem to want to help him with this situation. Okay, next on here, let's go here. So, okay, there's another question here where we listen to a track and understand what it's like being focused on.
Listen again to part of the conversation, then answer the question.
So, you signed up for extended borrowing privileges?
Yeah.
But we're still asking you to bring the book back?
Why does the woman say this?
But we're still asking you to bring the book back?
Okay, so to make sure she understands what the man's problem is, that sounds right. To encourage the man to return the book to library, no. To check whether the man has already returned the book, no. To explain to the man a change in the library's policies, no. This is A. So she's confirming, she's making sure she understands, she's making sure like that she's properly understood what the situation is. Okay, so that would be A. So going through here, the questions and the answers. So what are they speaking about? A book that the man is using to write a senior thesis and that he has to return it. She's offering, for number 2, she's offering to photocopy a chapter of the book for him. Number 3, what is, it should be woman, trying to explain when she mentions students have lost their borrowing privileges. It's she's explaining what will happen if he does not return the book. So, okay, how does the man probably feel? Appreciative, yes, that she is trying to help him. And then this last question 5, okay, why does the woman say, but we're still asking you to bring the book back? So she's making sure to understand the situation, the problem. So those are those answers there. So I hope you have gotten those answers correctly. And now we're going to move on to the last exercise here, which is another lecture. So I'm going to put this here, and this is in a geology class, and I'm going to play the audio file now. So listen and take notes, and then we'll take a look at the notes and the questions.
Listen to part of a lecture in a geology class. So, continuing our discussion of desert lakes, now I want to focus on what's known as the empty quarter. The empty quarter is a huge area of sand that covers about a quarter of the Arabian Peninsula. Today, it's pretty desolate, barren, and extremely hot, but there have been times in the past when monsoon rains soaked the empty quarter and turned it from a desert into grassland that was dotted with lakes and home to various animals. There were actually 2 periods of rain and lake formation. The first one began about 37,000 years ago, and the second one dates from about 10,000 years ago. Excuse me, Professor, but I'm confused. Why would lakes form in the desert? It's just sand after all. Good question. We know from modern-day desert lakes, like Lake Eyre in South Australia, that under the right conditions, lakes do form in the desert. But the empty quarter lakes disappeared thousands of years ago. They left behind their beds or basins as limestone formations that we can still see today. They look like low-lying white or gray buttes, long, narrow hills with flat tops, barely a meter high. A recent study of some of the formations presents some new theories about the area's past. Keep in mind, though, that this study only looked at 19 formations, and about 1,000 have been documented, so there's a lot more work to be done. According to this study, 2 factors were important for lake formation in the empty quarter. First, the rains that fell there were torrential, so it would have been impossible for all the water to soak into the ground. Second, as you know, sand dunes contain other types of particles besides sand, including clay and silt. Now, when the rain fell, water ran down the sides of the dunes, carrying clay and silt particles with it. And wherever these particles settled, they formed a pan, a layer that water couldn't penetrate. Once this pan formed,
Further runoff collected and formed a lake. Now, the older lakes, about half the formations, the ones that started forming 37,000 years ago, the limestone formations we see, they're up to 1 kilometer long, but only a few meters wide, and they're scattered along the desert floor in valleys between the dunes. So the theory is the lakes formed there on the desert floor in these long, narrow valleys. And we know, because of what we know about similar ancient desert lakes, we know that the lakes didn't last very long, from a few months to a few years on average. As for the more recent lakes, the ones from 10,000 years ago, well, they seem to have been smaller, and so may have dried up more quickly. Another difference, very important today for distinguishing between older lake beds and newer ones, is the location of the limestone formations. The more recent beds are high up in the dunes. Why these differences? Well, there are some ideas about that, and they have to do with the shapes of the sand dunes when the lakes were formed. 37,000 years ago, the dunes were probably nicely rounded at the top, so the water just ran right down their sides to the desert floor. But there were thousands of years of wind between the two rainy periods, reshaping the dunes. So during the second rainy period, the dunes were kind of chopped up at the top, full of hollows and ridges, and these hollows would have captured the rain right there on the top. Now, in a grassland and lake ecosystem, we'd expect to find fossils from a variety of animals. And numerous fossils have been found, at least at these particular sites. But where did these animals come from? Well, the theory that has been suggested is that they migrated in from nearby habitats where they were already living. Then, as the lakes dried up, they died out. The study makes a couple of interesting points about the fossils, which I hope will be looked at in future studies. At older lake sites, there's fossil remains from hippopotamuses, water buffalo, animals that spend much of their lives standing in water, and also fossils of cattle. However, at the sites of the more recent lakes, there's only cattle fossils. Additional evidence for geologists that these lakes were probably smaller, shallower, because cattle only use water for drinking, so they survive on much less. Interestingly, there are clam and snail shells, but no fossils of fish. We're not sure why. Maybe there was a problem with the water. Maybe it was too salty. That's certainly true of other desert lakes.
Okay, great. So this is a bit of a long lecture, but let's take a look at the notes here. So there's a set of desert lakes called the empty quarter in a huge area of sand in the Arabian desert. But so at some point, right now it's very hot, but at some point there were these monsoon rains, which is a lot of rain that used to fill in this area, and so as a result there were grasslands. But that was back 37,000 years ago, and another set was in about 10,000 years ago. So the lakes in the desert, there's an example compared to, I think, this Lake Eyre in Australia, and these lakes, well, they disappear. I should get rid of that S. And the limestone, they have these limestone beds, and there's like these low hills, and now there are these new theories about what caused these to form. And they've studied about 19 formations, and there's about 1,000. So there's still more to study. There are two factors that were important: that the rain was torrential, meaning there was a very large amount of rain, actually too much to soak into the ground, and that the rain, the water, contained particles of clay and silt, and together that formed a pan that was impenetrable. So looking at the other lecture, we had the word permeate, and here penetrate. So these are kind of related. As a result, this formed a lake. The water would not go soak into the ground. So they have these limestone formations about a kilometer long, but only a few meters wide in these long, narrow valleys. And the lakes maybe lasted just a few months or maybe even a few years. And then the smaller ones kind of dried up more quickly. So we have these old versus new, meaning old of like 37,000 years ago, and these new ones about 10,000. And so the new ones are higher up on the dunes, because due to the shape of the sand dunes, meaning that like originally these older ones, they were rounded at the top, but after thousands of years of wind that have kind of chopped off the top, this meant that those tops had like some irregular shapes and that they could actually hold the water. So the lakes are now, some of the smaller ones are located at the tops of those dunes and hills. Another thing that the professor mentions is that there have been fossils being studied to see the types of animals that would have been in that area, and they were wondering what maybe the origin of these animals were. So maybe they migrated from nearby habitats, and then when the lakes dried up, these animals died. For the older lakes, there are examples of hippopotamus and water buffalo, and those are animals that would stand in water, which meant that there would have been a large amount of water. And then there's evidence of cattle, but apparently cattle only use water for drinking. So there wouldn't have been enough water for like these bigger animals, like the hippopotamus or the water buffalo. So that shows that there was like less water. There's also evidence of clams and shells, but no evidence of fish. So the professor wonders if perhaps in comparison to other lakes in the desert, maybe this is because the water was too salty for fish to survive. So those are some of the notes that I have taken here. So let's get into the questions. Okay. So on here, what is the lecture mainly about? So reasons that geologists study lake fossils in desert regions. No. A comparison, ancient and present day lakes in the desert environments. No, these are two ancient like sets of lakes from 37,000 and 10,000. Geological evidence for the formation of ancient sand dunes. A hypothesis for how some ancient desert lakes formed. Yes, it would be this one, that there's these theories about what happened. Next, what is the professor's opinion about the conclusions of the recent study of the limestone formations in the empty quarter? They have changed the way geologists study desert environments. They contradict findings about similar desert lakes. No, they contradict this. They explain the causes of monsoons. No, they're not explaining that. They're saying that the monsoons were contributing to these lakes. They need to be confirmed by additional studies. Yeah, they said that. He said that there's only been a few of these lakes that have been studied, but there's additional research that needs to be done. So yeah, this would be D for number 2. The other ones just seem misleading, or the information was not involved in that lecture. Okay, next here. So according to the professor, what feature of the sand dunes made the formation of the lakes possible? The degree of slope of the sides of the dunes? No. And the presence of clay and silt particles in the dunes? Yes, that did help create this bottom for the bed, so that the water would not penetrate the soil or the ground. So I think it's B here. So the position of the dunes relative to wind and rain? No. The narrowness of the valleys between the dunes? No. I don't think it's C or D. So I would say here it's B. It's because of this clay and silt particles that made it impossible for the water to penetrate the ground. So next here, so how is it possible to determine in which rainy period a lake was formed? Well, there was the position of where the lake was, if it was at the top of a hill or at the bottom, and there was also these animals, seeing like the hippopotamus or cattle. So if I keep that in mind, so by examining the location of the lake bed, yes, by measuring the amount of sand coming in the lake, no, that's not true. By examining the color of the limestone, no. By identifying the types of fossils found in the limestone, yes. So this would be A and D, the location and the types of fossils. Okay, next here. Okay, what does the professor imply about the lack of water buffalo and hippopotamus fossils in the more recent lakes? That they were, I think, shallower, that there was like less water. So the level of water in the lakes was not sufficient for these animals. Yeah, that I would say A, because the amount of water. The bottoms of the lakes were too sandy. No, The location of the lakes made them too difficult for these animals to reach. No. The vegetation near the lakes did not attract. No. So I would say this is A. So this is, yeah, it's related to the amount of water in the lakes. So that was, yeah, A. And lastly, what possible explanation does the professor give for the apparent absence of fish? He said something about it being like maybe too salty, and that was not probably the right environment. So the presence of predators, no. The lack of appropriate food, no. Lack of suitable water, yeah, it was not the right water. So this would be C. The extreme desert temperatures, no, he didn't say that. So this would be C here. So I'll go into these last roundup of the questions and answers. So what is the lecture mainly about? Hypothesis for how some ancient desert lakes formed, yes. What is the professor's opinion about the conclusions? They need to be confirmed by additional studies, yes. According to the professor, what features of the sand dunes made the formation of the lakes possible? It's the presence of the clay and silt that made this impossible for the water to penetrate. So it's the B. How is it possible to determine in which rainy period a lake was formed? So it is here the location of the lake bed on at the top or the bottom of the hill and the dune, or by identifying the types of fossils. So he talks about those animals in their presence. And then what does the professor imply about the lack of water buffalo and hippopotamus fossils? That the level of water in the lakes was not sufficient for these animals. A. And lastly, 6, what possible explanation does the professor give for the apparent absence of fish in the most ancient lakes? So that's lack of suitable water. It was salty, probably, so that was not a right type of water for these fish to be able to survive. Okay, great. So I'm going to stop sharing my screen now, and you'll be able to see me here. So thank you very much for going through these listening questions and answers with me. So I hope you have found this useful, and this kind of wraps up these about 15 lessons that we've done for the TOEFL. You can go back again through the playlist. We have like an introduction video for the TOEFL versus the IELTS. Then we've done 6 lessons for the speaking section of type 1, type 2, 3, 4, 5, 6. And then we did 4 videos for the writing section. So we did 2 for the integrated essays, and we did 2 for the independent essays. Then we did 2 videos for the reading section, and then now we've done 2 for the listening section. So you have a lot of content to go through, a lot of tips and advice, and I hope you have found this very useful. So we're not going to be doing a lesson next week because we realize that a lot of students are going to be in a very busy exam period. So we're going to be skipping next week, but we will be back soon with more content to help you with your exam preparations. So thank you very much for watching, and see you soon. Bye.